We want to first, well, what we're looking at here is problem 1.1, I'll call it, on the catch-up problems. This is the first group of problems, first problem on this first set you got. We want to look at, the problem asks you to use the discriminant to determine how many solutions there are to a given quadratic equation. Now there are three different cases that could occur, as we're going to see. And you should actually, at this point, pretty much be aware of that. In any case, the quadratic formula says an equation of the form y equals ax squared plus bx plus c, the standard form of the quadratic, the standard expanded form of the quadratic. That expression is 0 if and only if x is equal to negative b plus or minus the square root of b squared minus 4ac, all that divided by 2a. And we know this formula. I hope we know this formula. In orange, I've written the discriminant. The discriminant is what's under the square root sign. It's b squared minus 4ac. So, b squared minus 4ac is the discriminant. Now let's see what the discriminant tells us about solutions to the equation. Excuse the delay, there's a little noise in the hall, and it's getting close to the time for classes to start this evening. Okay, so it's going to get noisier. Okay, well, let's take the equation y equals x squared plus 3x plus 5 and just first see what the discriminant is. Okay, the discriminant is what? It's b squared minus 4ac, and that's equal to what? Well, we could note that a is the coefficient of x squared, so a equals 1, b is the coefficient of x, that's 3, and c is the number you have left over in the ax squared plus bx plus c form of the quadratic function, okay? And let's say this is an equation so that this is equal to 0, and each of these is an equation, so let me just fill that in. Okay, so the discriminant is b squared minus 4ac, and b is 3, so that we have 3 squared, and then it's minus 4 times a is 1, and c is 5. Well, we can do the arithmetic. That's 9 minus 20, that's negative 11. Okay? Now, how's that going to work with the quadratic formula? Well, that's a number we're going to put in here. Okay, so that x squared plus 3x plus 5 equals 0 if and only if x equals negative b, in this case that would be negative 3, plus or minus the square root of, well, we just calculated b squared minus 4ac, it's negative 11, divided by 2. Okay? Now we didn't really need to write the negative 3 or the 2 in to see that the square root of negative 11 is an imaginary number. Okay, so this is, we could write this as negative 3 halves because dividing by 2 distributes here. So negative 3 over 2. And actually, yeah, it's supposed to be 2a, so it's 2 times 1. Let's be explicit why we got the 2 there. 2a, 2 times 1. And that's plus or minus the square root of negative 11. What's the square root of negative 11? Well, that's the square root of 11 times I, where I is an imaginary number, and yeah, we're pretty good with imaginary numbers. So we can see that x is negative 3 halves plus or minus the square root of 11 over 2i, an imaginary number. Okay? Well, that's two complex solutions. So we have two complex valued solutions. and they're of the form something plus or minus some real number plus or minus an imaginary number. And we also call these complex conjugate solutions. Okay, so the lesson here is when the discriminant is negative, we're always going to have a negative number under here, so we're always going to have the square root of whatever that number is times I. So negative discriminant implies the same thing's going to happen. Complex conjugate solutions. That's what happens when you have a negative discriminant. Now let's see what happens with this equation. Okay, the discriminant well, first of all, A is negative 2, B is negative 6, and C is 3. So the discriminant is B squared minus 4AC, which equals negative 6, quantity squared, minus 4 times negative 2 times 3, which is what? That's 36, and that's, let's see, 4 times negative 2 is negative 8 times 3 is negative 24, and the minus that is plus 24, so that's 36 plus 24, which is 60. Okay, so our solution is x equals negative b, which is negative of negative 6, plus or minus the square root of, well, just 60, that's our discriminant, divided by 2 times negative 2. Okay, well, we can simplify that a little bit, but we have a positive here, a negative here, that's 6 over 4, which is 3 halves. Dividing this by this, and then dividing this by this, we're going to have plus or minus the square root of 60 over negative 4. Now, plus the square root of 60 over negative 4 and minus the square root of 60 over negative 4 together give us either plus or minus the square root of 60 over 4. If we have a negative 4 down here, we have a plus and minus up here, so we still get both the same solutions. So this equals, of course, square root of 60 is the square root of 4 times the square root of 15, which is 2 times the square root of 15. So this is 3 halves plus or minus 2 square root of 15 over 4, which is 3 halves plus or minus the square root of 15 over 2. Now, you don't have an I on this, you don't have a square root of a negative. This is a real number. Okay, you can approximate it with your calculator, but you don't get it exact. The exact form of this number is just what we have here. Okay? Both of these solutions are real numbers. Okay? So we can say that anytime we have a positive number under here, then we're going to get something plus or minus that positive number over something else, okay? But we're going to have a plus and we're going to have a minus, and since we have a positive number from the square root, we're going to get two solutions, one for the plus, one for the minus. So positive discriminant implies two real solutions. One for the plus, one for the minus. So what happened here with this equation is going to happen anytime your discriminant is positive, and the thing that determines how many solutions and what kind of solutions you have is just whether that discriminant is a positive real number or something else. If it's a positive real number, you get two solutions. Same thing happens that happened here. If it's a negative number, you get two complex valued solutions, one for the plus, one for the minus, because this is always going to be an imaginary number. Those are complex conjugate solutions. Now there's a third case, and this chalk is getting awful short, but I think I can make it. Okay, the discriminant here is, and I'm just going to write it out, it's b squared minus 4ac. b is 6, so it's 6 squared minus 4. A is 1. C is 9. And you work that out, you get the square root of 0, which is 0. So what does the quadratic formula say in this case? It says that your solutions, but there's only going to be one of them, it turns out, are negative b, which is negative 6, plus or minus the square root of 0, divided by 2 times 1, which is negative 3, plus or minus 0. Now, whether you add or subtract 0 with your negative 3, you're going to get negative 3. Negative 3 is your only solution, but it occurs twice. Once for the plus, once for the minus. So we call that a repeated real solution. So we can say discriminant 0 always yields a repeated real solution. Whatever you get from the B over the 2A, that's going to be it. If your discriminant is 0, plus and minus don't do anything except give you the same result twice, a repeated real solution.